Hello everybody, I'm back for one more video for your grade 12 students. Realized that maybe I should do a quick review video about chapter 23 and 24, what we can do with our TI Inspire within those two chapters. Okay, so basically there's 4 different functions we're doing with our TI Inspire, and those 4 functions all come from doing menu, probability, distribution, and then we have 4 choices after there that we are using. There's a lot more than 4 choices there, but we are using 4 of them. Okay, so the first one is binomial PDF. So when do we use this? Second one, binomial CDF. When do we use this? The third one, normal CDF. And the fourth one, inverse normal. Okay, so we learned about these first 2 in chapter 23. We learned about these last 2 in chapter 24, but you may have noticed if you continued on with the curriculum in sections C and D, that sometimes we need to revert back to binomial situation once we have figured out our probabilities from the normal distribution. Okay, so binomial. Here, binomial PDF. This is when we have x is distributed binomially. Okay, distributed binomially. So what makes that happen? Probability that something is happening or not happening. Okay, so both of these, let's see here, both of these are x is distributed binomially. Both of these are x is distributed normally. Okay, so here we only have 2 choices. Either we looking for the probability of something happening or something not happening. Okay, so we will be using binomial PDF. Okay, so and this is usually happening if we're choosing a random item, choosing something from a random sample of x of a number of n number of things. Okay, so we will use binomial PDF when we're looking for only one term within that binomial expansion. Okay, this also has to do with binomial expansion, probability of something happening plus the probability of something not happening to the power of n, and then being able to expand that out. Okay, so only one term we're using when we're using PDF. We're only looking for one of those terms. In binomial CDF, we're looking for a range of terms to add together. Okay, so in this binomial PDF, you'll get to your pop-up screen after you choose binomial PDF, and you'll have to put in your n, and you'll have to put in your probability of success, and you'll have to put in your x value, which is the one term you're looking for, and that x is how many successes are you looking for? Okay, how many successes are you looking for? This is the probability of success, how many successes you're looking for, and this is how many trials are being done. So how many are in the trial. Okay, range of terms to add together. When your pop-up screen comes, you're going to have your n. So again, how many here. You're going to have your probability of success again, and then you're going to have your lower bound and your upper bound. And remember, these values here can only be integers, okay? Integers, because discrete random probabilities, we are counting things. All right, now over here we are measuring. So that's another thing to remember about, actually. In both of these, we are counting. Okay, over here we are measuring. And if it says that data set is normally distributed, then, and we want to find the probability. Okay, so if we are finding probability, then we use normal CDF. Okay, CDF means a range of values, which we talked about in one of our videos within within chapter 24, where we you cannot just find a value under the curve, the area under the curve of one teeny slice. You always have to be finding the area of a curve that we actually can take the area from, because the area of one teeny slice will actually be 0, okay? It's because it would be so small, it would be 0. So we have to take a range of values. So with normal CDF, we're finding probability. What happens there when our pop-up screen comes is, I forget what happens. We get, I'll just see here, menu, probability distribution, normal CDF. Yes, lower bound and upper bound comes first. Okay, so we get lower bound, we get upper bound, and then we have the mean and the standard deviation. So that's if we know the mean and standard deviation. Now, if we don't know the mean or the standard deviation, we can go back to our Z distribution and find that with our inverse norm. Okay, but or find the Z score using our inverse norm. Okay, inverse norm, we're going to use that when we already know the probability. We know the probability, but we don't know the K value. But we don't know, so we're finding a certain X value in our data set. That area is that the area is smaller than that X value. If we're using the Z distribution, so mean of 0, standard deviation of 1, then we would be finding a Z value. Okay, so the four main, what happens here is menu, probability distribution, inverse norm, area we have to put here, and then mean and standard deviation. And if we're looking at the Z distribution, the mean is 0, standard deviation is 1. If we're looking at an X distribution, then you have to be able to put those values in. Okay. So 4 things basically that we did with our tinspire in chapters 23 and 24. 2 of them had to do with counting, binomial distribution, binomial PDF and CDF. 2 of them had to do with measuring things. Now, when we got to the further sections within chapter 24, normal distribution, after we have found a probability, sometimes the question goes on asking a binomial situation, which then you have to go back and do some of this work again. Okay, so you will know when that happens, when all of a sudden you're counting how many of something is happening and you're choosing a random discrete sample. Okay, hopefully that will help you. I just want to double check one thing and make sure I get the right pop-up boxes here. Menu, probability distribution, binomial PDF, number of trials, probability of success X, yes. And menu, probability distribution, binomial CDF, number of trials, yes. Probability, lower bound, upper bound. Okay, excellent, good. See you guys.